Hi class, this video is going to be about rational exponents, and mainly our goal today is going to be able to convert between rational exponents and radicals and then use those rational exponents to simplify our radicals as well. So it's kind of an extension of the last section. As we get started in this video, I want to show you basically the first example. We have seen things before where it says the square root of 5. Okay, so this should look pretty familiar. And this is in its radical form, and we can change the radical form to what we call our rational exponents. In other words, we get rid of the radical and we write our square root as an exponent. So to write the square root of 5 from radical form to exponential form, we would write it 5 to the 1/2. And the same thing would apply if we were to do something like the cube root of x. If you were to rewrite that into radical form, or to exponent form, it would be x to the 1/3. Maybe you'd even have the 5th root of 2, so this would be written in exponential form as 2 to the 1/5. So notice that my index, so the number that's here with the root, 2, 3, and 5, goes in the denominator of the fraction, and then the exponent that's with the number underneath the radical, so the radicand, goes on the top. So these were all 1s, so 1s would go on the top. But I could have something, for example, the 4th root of z to the 3rd. So if I wanted to rewrite this in its exponential form, that would become z to the 3/4. The index goes on the bottom, the exponent here goes on the top. And then of course you would want to reduce if possible. So how about you try this example? If we have the cube root, of c to the -5th, you could try that one. Or you could also try the changing d to the 7/4 into the radical form. So the first one, change it to exponential form. Second one, change it to radical form. See how you do. For this first one, you should have gotten c to the -5/3. And this is something where we have to remember our exponent rules, because you could change this to 1 over c to the 5/3, because remember, negative exponents get flipped to the denominator. And then in number 2, you could have rewritten this as the 4th root of d to the 7th. The index is the denominator, the top number is our exponent with the letter. And we're done. All right, so that's the basics of rational exponents. Now we're going to use these concepts to simplify more complex radicals. So let's go through a couple examples here. Now let's try the first one. If I've got, 81 to the -1/4. So we're going to go ahead and work on simplifying. That might be what your directions say. So the first thing that you could pay attention to is that there's a negative exponent. So remember, negative exponents are going to go to the denominator. So we'd have 1 over 81 to the +1/4. Hopefully you remember that rule. But then it's hard to know what 81 to the 1/4 is just looking at it this way. So the easiest thing to do in this case is to change it to its radical form. So I'm going to have 1 over the 4th root of 81. And then the problem here is that we can't easily see if this is going to cancel nicely. Okay, you may not know what your 4th roots are off the top of your head. However, we could figure out that 3 to the 4th gets us 81. So I could go ahead and rewrite this if I wanted to as 1 over the 4th root of 3 to the 4th. So I just changed the 81 to a 3 to the 4th. Those are the same. And now we should know from previous lessons that when you have an index and an exponent that are the same, they're going to cancel each other out. It's just like having a square root with an x squared. They cancel and you're left with x. Same thing. So these are going to cancel out, and I'm going to be left with 1 over 3 because my 4th roots would cancel. So it would look like that. Okay, so my final answer for this one would be +1/3, and then we'd be done. What if you go ahead and try this one? So let's say we have -3,125 to the -1/5. So try that one, and if you want me to check it in class, I can do that, but see how you do with simplifying.